going to be about probability. We're going to start with applying ratios to probability. Theoretical probability is what is supposed to happen. It's going to be between 0 and 1, 0% to 100%. We have to reduce our fraction. So we have a certain type of notation. This P right here represents probability. And then in the parentheses is going to be of what you want. And then it's going to equal a fraction. The fraction on top in the numerator is the number in the group you want. The bottom, the denominator, is total number of things there are. For example, rolling a dice / numbered cube. I'm looking for the probability of rolling a 4. So out of that whole dice, there's only one side out of all 6 of them that have a 4 on it. So the probability is going to be 1/6. If I change that to a decimal, I'm going to get 0.16 repeating. So approximately about 16% of a chance to roll a 4 on a die. If I wanted to roll either a 1, 3, or 5, I would have a 3 out of 6 chance. But if I reduce that, I'm going to end up with 1/2. So that means the probability of having those 3 sides out of the 6 sides would be about 1/2. Okay? So let's do an example. A bowl contains 12 slips of paper, each containing the name of a different month. Find theoretical probability the month selected will end in ber. So, out of the 12 months, we have September, October, November, and December. So the probability of picking those 4 different months, they end in a ber. So I have what I'm looking for, so 1, 2, 3, 4, over how many in total. There are 12 months in total, so I put 4 over 12. This reduces down to 1/3. So there's a 1/3 chance of picking a piece of paper out and the month ending in a ber. Example number 2. For a number cube, find the probability of a number not being divisible by 2. So probability, P, parentheses, number not divisible by 2. Okay? Numbers not divisible by 2 on a dice are 1, 3, and 5. So there's a total of 3 of them. And out of all the sides, we have 6 sides. If we reduce that, I get 1/2. Okay, so there's about a 50% chance of rolling that cube and not getting a number divisible by 2. There are also compound probabilities, where there's going to be 2 or more events. An example, tossing a coin and then rolling a die. Another example is picking one name, putting it back in the basket, and then picking another name. The 2 types of compound events are independent events that do not affect one another. So if I'm rolling one dice and I want 2, and I roll another dice and I want another 2, those do not affect each other. But the dependent events that do affect each other are if I have marbles in a bag, I pick one out, and then I go without replacing. I do not replace that marble, and I take one out. So that means when I took that first one out, I'm going to have one less marble in my total when I'm going to pick out the second one. Alright, let's look at independent first. Okay? Independent events. There's ones that don't change when the experiment is done. Example, rolling a dice, flipping a coin, spinning a spinner. When I spin them, nothing really changed. Okay? But then there's an example with replacement. So an example is we select a name out of a bag, and then we put that name back in, so that person can win more than one time. Okay? If the name was not returned to the hat, that person could not win again. But so with the independent events, we would pick a name and then put it back in. Example number 1, we're going to roll a number cube. What is the probability you will roll an odd number on the one cube and a multiple of 3 on the other? So we would write this: probability of rolling an odd number and multiple of 3. So what we're going to do is when we have compound events, we want to first find the probability of the first event, then multiply it by the property of getting the second one. So if we roll that die to get that first number, to get an odd number, I would have 3 out of 6. There's a 3 out of 6 chance of rolling an odd number. Then we are going to multiply it by the chance of rolling a multiple of 3. So that would just be 3 and 6 on a dice. So I have 2 out of 6 chances to roll that dice. Okay? To make my numbers a little bit simpler, I'm going to reduce first. So I'd get 1/2 times 1/3. And when I multiply fractions, I multiply the top. 1 by 1 gives me 1. 2 times 3 gives me 6. So the probability of rolling an odd number and then my second roll being a multiple of 3 would only be a 1/6 chance. My second example, roll a red cube and a blue cube. Find the probability of getting a red, a 5 on the red cube, and a 1 or 2 on the blue cube. Okay, so my probability of rolling 5 on red cube and 1 or 2 on blue cube. Okay. Probability of rolling a 5 on the red cube is going to be 1/6. We're multiplying it by how much it would be to roll, the probability of rolling a 1 or 2 on the blue dice, so the blue cube. So I would have 2/6. Reduce this one fraction, I'd have 1/6 times 1/3. I'm going to multiply those out, and I'm going to have 1/8 of a chance to roll a 5 on the red cube and a 1 or 2 on the blue cube. Okay. This example number 3 is the example of independent events, but that second one. So selecting with replacement. Suppose you have 3 quarters and 5 dimes in your pocket. You take out 1 coin, put it back, then select a second coin. Find the probability of selecting a dime and then a quarter. Okay, so we're looking for the probability of picking a dime, then a quarter. Then a quarter. Probability of picking out a dime. I have 5 dimes, 3 quarters. So I have 5 on top. And then the total amount of coins I have in my pocket are going to be 8. We're going to multiply it by the probability of then picking a quarter. So I have 3 quarters. And if I replace that coin that I first picked out and put back in, I still have 8 coins in my pocket. We multiply, there's nothing to reduce here. 5 times 3 is 15. 8 times 8 is 64. And we cannot reduce that at all. That's all we have. 4, you are given 15 game tiles that are only vowels. These include 4 A's, 3 E's, 2 I's, and 4 O's, and 2 U's. Find the probability of selecting a U and then an I with replacement, meaning that when I take out my first one, I'm putting it back in, so our total will not change. So probability of picking a U and then an I. Probability of picking out a U. The total amount of U's I have are 2, and how many game tiles we have in total are 15. I'm going to multiply it by how many, the probability of picking out an I. There are going to be 2 I's out of 15 because we're replacing. We multiply them, I get 4 over 225. Cannot reduce that, so the probability of picking U and then I with replacement is 4 over 225. Alright, that's with replacement. The next one that we are going to go over is dependent events without replacement. Dependent events influence each other. The first event affects the second one's outcome. Example 5. Suppose you have 3 quarters and 5 dimes in your pocket. Take out 1 coin from your pocket and do not replace it. Select a second coin. Find the probability of selecting a dime and then a quarter. So the only thing that's different with this example is that now when I pick out that second coin, I didn't replace the first one. So to select a dime, we still have 5 of them in our pocket and 8 total coins. But I do not replace that dime. So when I go to my next one to find out what's the probability of a quarter, I now have 3 quarters still in my pocket, but I've taken one away, 1 coin, one of our totals. So that's why we have a 7 for this. Okay? We took a coin out. That's why it went down to 7. We multiply the tops before, like we did before. 5 times 3 is 15, 8 times 7 is 56. So this is an example of a dependent event where we are not replacing what we take out the first time. So, we're going to go back to that example that we had before with these tiles when we had vowels. So we're finding the probability that you will choose a U and then an O without replacement. So probability of U, and then O, without replacement. Okay? The probability of picking an O out of these tiles down here, there's 2 O's, and there's a total of 15 different tiles. But once I take that O out, there's 1 less O and 1 less of our total. So for the next one, when I'm trying to find out, when I'm picking my second one out, when I have that O, instead of having 15 total, I now only have 14 total. Because I took one out and I did not replace it. Out of all of those, I have 4 different O's. Right? Can't simplify that first one to 15, but I can simplify that other one. I get 2 over 7. When I multiply everything out, I have a probability of 4 over 105. Okay, probability of 4 over 1 over 5. And that's our answer for this one. Example 6b is a little bit different. It's saying find the probability that you will choose a U and then a U without replacement. Okay? So property of U, then U, no replacement. Okay? So same thing. I am now picking out of there, out of those 15 total, 2 of them actually 16 of them. 15, sorry, 15. 15 in total. And then, once I take that one U out, I do not replace it, so my total goes down by 1. So we'll multiply by 14. But not only does my total get replaced, now I have one less U in these tiles. So I take out this U after I pull one out, and I'm only left with one U out of all 14 of those. What I'm going to do now is the same. We just multiply them out. I'll get 2 over, actually, we won't get 2 because if we reduce, I will get 1 over 105. That's our probability of that one. Okay. This one right here, this example is telling us a teacher must select 2 students for a conference. The teacher randomly picks names from among 3 freshmen, 2 sophomores, 4 juniors, and 4 seniors. What is the probability that a junior and then a senior are chosen? Okay, so for this one, there's a total amount of kids are 13. If I add up 3 plus 2 plus 4 plus 4, there's a total of 13. So probability of a junior, then senior. Okay, first my juniors. There's 4 juniors out of 13. Okay, but if I take that junior out, there's no longer 13 total, there's only 12. And since I'm looking for seniors, I'll have 4 over 12. When I multiply and reduce, I'll get 4 over 39. That's the probability. Okay. I'm going to ask you to finish those last 2 on your own. If you have any questions, please raise your hand.